Alright, chemistry kids, here we go. Last part of the mole unit. Now we're going to talk about empirical and molecular calculations. Alright, and this has all the different types of calculations we've done. It deals with percent composition, it deals with grams to moles, it deals with distributing subscripts, all that kind of stuff. So it's kind of putting everything together. So make sure when you guys go through this stuff, make sure you know what empirical molecular formula are to start with. And also make sure you know what the question is asking you to find. So for a quick review, the empirical formula is simply the simplest whole number in a formula. In other words, it can't be reduced. So an example of that would be like NaCl. Okay, can't reduce it down anymore. That's what it's going to be. So, simplest whole number, in other words, you can't reduce it down. The molecular formula is how the formula naturally occurs. So it's the natural formula. Say, for example, like propane. Propane is a fuel we use mostly for like grills and things like that, and sometimes for houses. Propane formula is C3. Let's see, C3, I believe H8. Yep, that sounds right. Okay, so is that the empirical formula? And the answer is yes, this is actually an empirical formula. All right, this one can't be reduced. All right, but then we also have formulas like C4H10, which is just adding on a carbon. But now if we look at C4H10, can that be reduced? And the answer is yes, it can be reduced. All right, so therefore this is the molecular formula. Okay, molecular. And then they said, well, what's the empirical formula? So reduce that down, divide each one by, we're going to go by 2. Then it would be C2H5, which I can't reduce down. So molecular means it can be reduced down, how it actually exists. Empirical means it cannot be reduced. It's in simplest form. All right, so realize what they're asking you for when you talk about these questions. So the first question here, it says a compound with an empirical formula of C4H4O and a molar mass of 136 grams per mole, what is the molecular formula? So the first thing you need to do in these problems is find the weight of the empirical formula, or the molar mass, or the formula mass, or the gram formula mass, whichever one your teacher uses. So I know that for carbon, I have 4 carbons, each weighing 12.011. I know that I have 4 hydrogens, each weighing 1.0079, I believe. And I have 1 oxygen weighing 15.999. So we do these calculations. All right, and you just do a straight calculation here. Hopefully you can see that. It might not be able to turn the light on. Can you see it better? Kind of, sort of, maybe. So 4 times 12.011 gives me an answer of 48.44. 48.44. Then we do the other calculation. 4 times 1.0079 gives me an answer of 4.0316. And obviously 1 times anything is the same number. Now we add these up. So we add up 48.44 plus 4.0316 plus 15.999, and you get an answer of 68.4706. All right, now what did I just do? All right, let's be honest. Some people have no idea where the numbers came from. So what you need to realize is this. I know I have 4 carbons in the formula because of the C4, because of the subscript that tells me how many atoms I have of that element. This number, the 12, the 1.0, and the 15.9, that is the weight of that particular element on the periodic table, the atomic weight. So I just times how many I have by the weight, and I get the total weight of that element in the formula. I add all those up. This is my empirical formula mass, or molar mass. So in other words, how much the empirical formula weighs on the periodic table. All right? So that's what I got to do. Next step, once I find my weight, is I take my 136, which is my molecular mass, okay, the mass of the molecular formula, divide it into my empirical formula mass. And if you do that calculation, 136 divided by 68.4706, you get like 1.99, which is basically 2. So I have a factor of 2. I distribute that right into the empirical formula. So if I had 4 carbons to start with, 4 times 2 means I have 8 carbons now. So C8. Same thing with hydrogen. I have 4 hydrogens to start with, 4 times 2. Now I have 8 hydrogens. I have 1 oxygen to start with because the ones are understood, not written. 1 times 2 is 2. Here is my molecular formula, how it actually exists. All right, so what we basically did in that problem is have the empirical formula, figure out the molecular formula. All right, so what you got to do, if we think about it in steps, first step, find the empirical molar mass, or some people call the molar mass formula mass, or some people call the molar mass gram formula mass. It all means the same thing. All right, that's what I did here. Second step, divide, okay, the molecular mass divided by the empirical mass, which is what I did right here. And they will normally give you the empirical mass in the formula, or in the word problem. All right, that's what I did. I got a factor of 2. And then what I do for my third step is simply distribute factor into the empirical formula. Oops, can't quite see that. Distribute into the empirical formula. There you go. And those are basically the 3 steps. This should be familiar from like percent composition and finding like molar mass, things like that. This is obviously just straight division, which we should be able to do. And this is just distributing that factor into the empirical formula. All right, so hopefully that sounds familiar, but 3 basic steps for those problems. So the 3 basic steps are for problems when you are given the empirical mass and trying to find the molecular mass. All right, so make sure when you read the word problem, you know what they're asking for. Let's try another brand of formula. In this one, instead of finding the molecular mass, now we find, or the molecular formula, now we have to find the empirical formula. So if you look at this problem, it basically tells you have a compound made up of nitrogen and oxygen. You don't know how much nitrogen and oxygen, okay? But we do know that 36.84% of this is nitrogen. So I know that 36.84% is nitrogen. And since the only other element in this compound is oxygen, 100 minus 36.84 gives us the wonderful world of 63.16%. All right, so now we know how much each element makes up the compound. First thing we gotta do is assume that we have 100 grams. So what we did here is we found a percent composition, really. All right, so just change our percent to grams. No real math involved. Just basically assume that you have 100 grams. So now the 36.84% becomes 36.84 grams. The 63.16% becomes 63.16 grams. Simple label change. It's just how you think of the number. All right. Now, once we have our grams, we're going to do a calculation we've done before. Grams to moles. All right. So this is where we look at our mole wheel and we say, how do we go from grams to moles? Here's our mole wheel. So grams is down here, moles is up here. Here's my step. 1 mole over my molar mass or formula mass or gram formula mass, whatever you call it. All right, so basically the weight of the compound or element we're using. So 1 mole goes on top. in both instances. And the molar mass goes on the bottom. So what is nitrogen's weight on the periodic table? And I believe it's 14, double check here, 14.007? Yep, I was right. 14.007, and then oxygen's is 15.999, and then we just got to do that calculation. So 36.84 divided by 14.007 gives me an answer of 2.63 moles. And then we do the other calculation. 63.16 divided by 15.999 gives me 3.94 moles. All right? So now we found our moles. We're chugging along here. Now what we do once we find our number of moles is we divide each number by our lowest number of moles. So obviously 2.63 is the lowest, so we divide by 2.63 here, and divide by 2.63 here. So obviously 2.63 divided by itself is 1. 3.94 divided by 2.63 is 1.49, which you can just round to 1.5. Now these numbers, if they come out to nice whole numbers, are going to be your subscripts that go with each element in the formula. And if they don't come out to nice whole numbers like they did here, you have to multiply them out to get nice whole numbers. So the best thing to do is to start with the lowest number, like multiply it by 2, then maybe multiply it by 3 and see which one comes out the lowest. In this case, we multiply both by 2, we get a 2, we get a 3, those are our factors. So now my empirical formula is 2 nitrogens, 3 oxygens, N2O. There's my empirical formula. All right, so now let's think about how we did this. First thing we did, this stuff right here. We found our percent composition. All right, that would be the first step. Second step, right here, what do we do? Well, we just change our grams, our percent to grams. Simple label change, nothing crazy. Percent to grams. Okay, once we get our grams, what do we do here? Oh, we changed our grams to moles. Change our grams to moles. All right, so now we found our moles right here. Then what did we do? Well, we divide by our lowest number of moles. Get some room here, there we go. So fourth step, divide by lowest number of moles. All right, oops, not a very good S. All right, that's what we did there. And then we got these numbers. If needed, not always, because sometimes these numbers come out really nice, sometimes they don't. And then we'll multiply to get whole numbers. Keywords, if needed. Okay, because you might not need this to multiply this out every time. Sometimes these numbers will come out nice and whole. All right, so find your percent composition, percent to grams, grams to moles, divide by your lowest number of moles, and then multiply to get the whole number if you need to do that. Sometimes you don't. And then just plug them in. So you have 2 nitrogens, 3 oxygens. All right, so now notice how this problem here, we're trying to find the empirical formula, whereas the other problem, we're trying to find the molecular formula from the empirical formula. So make sure when you read these problems, you realize what you're trying to do, what they're giving you, and what you're trying to find. So there's different steps involved. One's a little more mathy, the other one's a little more, I guess you could say simpler. All right, hope this video helped. We'll talk to you guys later. Have a good one. Bye.